Okay, y'all, we got through week one. I hope okay. I've heard from several of you, and I appreciate that. I had a student log in to the live hangout every day, and that was really cool. I missed ya. So every day I'm on Hangout from 9 to 10. Every day I'm on there live and in person. My camera's not working, but we can still chat with each other. If you want to do that, you go right here to classwork. The stream is confusing. You guys are clicking around and doing stuff out of order and maybe things you don't have to do or whatever. The stream is cool, but not as cool as classwork tab. Go to the classwork tab. Where's the classwork tab? I can't find the classwork tab. Oh, there it is. It's right there, right at the top, right next to the stream. That's called the classwork tab. That's where you want to go. Then right here, we've got our Google Meet link. So every day from 9 to 10, that's me right there talking to nobody except for one awesome person that showed up last week. She's amazing. I had someone else send me a video of them at their computer with their bird, which was pretty cool. I appreciate that. So if you want to hang out, the student that got on, I think just wanted to talk to y'all more than she wanted to talk to me. She was disappointed nobody else was there. So from 9 to 10 every day. Textbook login right here. And then there's the stuff you did last week. Here's week two right at the top. The only thing missing is this video. I can't post it until I make it. So right here will be the video. Then you're going to do the forces notes. I'm going to talk, and you're going to fill this stuff in. And then you're going to study it, and you're going to go take your quizzes for this week about the types of forces. Some other reminders. I'm there every day from 9 to 10. I also don't get away from my computer. I stay with my computer right beside me, turned on, where I can answer emails as soon as I get them. I answer within minutes between 8 and 12. So every morning until noon, I have my computer right beside me. I have it throughout the day, and I keep an eye on it all day and half the night long. But I'm actively looking at the screen between 8 and 12 every day, waiting for you to ask me questions. Outside of those hours, if you want a quick response, you should try this remind. Remind message comes right to my phone, and that should let me know that you need some help, and I'll go check out what you need. So the go to remind and sign up for this. You can do it on your computer too if you don't have a cell phone, which is why I didn't put the 81010 number. If you text this code on your cell phone to 81010 81010, that'll sign you up for a remind. Some other things. People all week long were having trouble typing in the document. I don't know why, because there was lots of people that weren't having trouble typing in the document. But if you cannot type in the document, there is a button I have to click to make you do it. So I'm sure I'm going to mess it up sooner or later. Maybe I did on this last one. I don't know. I don't think so. But if you ever can't type in here, you're in here and it won't let you edit. It won't type it. It says you need to request access or something ridiculous. Go right here, file, right here, file, make a copy, make your own copy, and then turn that copy in under the assignment where it says turn in. Do not email me your assignments. That's not how I'm going to do it. I cannot keep track of multiple assignments times 140 in my email. This would be literally 300 or 400 emails that I'd have to search around in and try to figure out who turned it in and who didn't. The whole point of Classroom, the main point of Classroom, is that I can go right here and I can look at your assignments from last week. Right here is the note guide, and I can say that these people turned it in, and I can look at them and grade them, and I'm going to do that here in a minute, and these people did not. So that's where it needs to be. I'm not taking work emailed to me. I'm going to tell you to turn it in. So if you don't know how to do that, figure it out. A big resource that you have besides getting on there and talking to me is ask your friends. Um, what else do we have here? Don't make a copy, or do make a copy. If you can't edit it ever, make a copy. Also, don't email me your assignments. I just said that. And we have already looked in Classroom and talked about where to find your work for this week. It's right here at the top, right here. So you're going to watch a video that's not there yet, fill in the notes, take the quizzes, and you're done. So the notes look like this. It's got some questions at the top. And then this box, you're going to fill in the type of force description. That's what I'm going to talk about right now. You're going to put the symbol in here, and then you guys are going to search for on the internet examples of each type of force, and that's what you're going to put in this last column. And that's all you have to do, this one page of stuff. So let's just jump right in there and get started. A force is, so this is the first question. I'm not going to switch back and forth too much. The first question on the paper that you're filling in is, what is a force? And the first thing here is asking you about that. Also, I've had some people, multiple people comment on me being like really, I don't know, not as fun and goofy as normal, but I'm trying to, excuse me, keep this video less than 10 minutes, and I'm probably already at 5 or 6 and I haven't even got started. So for, just so you guys can get your stuff done, I'm going to try to get focused and stay focused. I do miss y'all, and get on there and hang out with me. Okay, force is any push or pull on an object. The good news about the whole rest of the year is you've been getting forces and energy and all this kind of stuff since like 2nd grade. So you've heard this really literally since 2nd grade. A force is any push or pull on an object. And remember, I'm going to keep rolling. If I'm going too fast, just pause the video, fill it in, come back and answer the next question. There are 2 categories of forces. There are contact forces is the first category, and that's when objects are in direct contact with each other. Then there are field forces. This is forces, pushes, and pulls between objects that are not in direct contact with each other. And the next couple of slides are going to be examples of those, so I'm not going to elaborate on that anymore. Just type that in for the questions at the top of the paper, and we're going to clearly describe and define and get examples of both of those things in a minute. Again, pause. I'm sure I'm going too fast for you to switch back and forth. The 5 types of contact forces that your paper is asking you about are normal, friction, applied, tension, and air resistance is a type of friction. It's as an object moves through the air. It's also referred to as drag, and we're going to talk about all of these types of contact forces in a moment. A field forces, the 3 types of field forces are gravitational, magnetic, and electrical. So now we're down to the table. You've answered those questions at the top of this paper. What is a force? What are the 2 categories of forces? Define contact, define field, 5 examples of contact forces, 3 examples of field forces, and now we're going to go over the details of those forces right here in your table. So the first one is applied force. Applied force is a force applied by a person or other object. So if pushing a board across a table, pulling on a wagon, you guys should look up other examples of applied force. Is when a person or object pushes or pulls on another object, and the symbol for that is the capital F for force, and then which type of force, little a, force applied, F sub A. The next type of force is normal force. Normal force is the supportive force exerted on an object that is in contact with another stable object. If you've got your computer sitting in your lap right now, your lap is providing the normal force. It's keeping you from going through the floor. A table keeping a book from letting gravity pull it down towards the earth. That's normal force. My coffee cup is now sitting on the table beside me. Of course, I'm drinking coffee. The normal force is the supportive force of my table, and it works in the opposite direction of gravity, which is pulling down on my coffee cup. That is the normal force, F sub N. It's the supportive force that exists between 2 stable objects that are in contact with each other. Friction force is the force exerted by surfaces as objects move or attempt to move past one another. So friction force is always opposite of the direction of motion, OPPOSIT, opposite of motion. So the friction, the applied force is this direction. A person, here's this person's hand. Look at this beautiful artwork of mine. This hand is pushing here. This is your applied force, and our force of friction, either static or kinetic, which we're going to talk about in a minute, is in the opposite direction of motion. Here is our motion up here. So friction force is the force exerted between surfaces of objects as they move past or attempt to move past. That's what makes an effort. As they attempt to move fast, they don't always move. And that's what we're going to talk about right now. Again, remember that friction is in the opposite direction of motion. Two specific types of friction that we're going to talk about are static friction, friction between objects that are not in motion. Why isn't this guy's car sliding, rolling down the hill? Gravity is pulling down on it, and the F sub S, static friction, the contact between the tires and the road, is stronger than gravity pulling down on it. So there is friction in the opposite direction of attempted motion. Gravity, F sub G, gravity is pulling it down the hill, but static friction is holding it in place. Friction between objects that are not in motion is static friction, and friction between objects that are in motion is kinetic friction, right here, kinetic friction. This is a picture of Mrs. Gunterman when she was 6, sledding down a hill. And the friction, gravity is pulling her down the hill, F sub G. And remember that friction is in the opposite direction. So friction is opposing her motion, F sub K, kinetic friction. This is friction between objects that are in motion. Gravity is pulling down the hill, and friction is acting in the opposite direction. F sub K is kinetic friction when objects are in motion. Tension force, the force that is transmitted through a string, rope, cable, wire, backpack, strap, whatever, when it's pulled tight by forces acting on opposite ends. So you've got, here you are, and you've got your backpack on. Let's not even do that. Let's do a purse here. Here's a person's hands, and they're holding on to their purse. There's your purse down there. This is a tension force. The purse is pulling on one side of the strap, and your hand is pulling on the other side of the strap. Here we've got the crane pulling on this cable down to this wrecking ball. The crane is pulling on one side of the strap. The ball is pulling on the other side of the strap. Tension force, F sub T. When a force is transmitted through a string, rope, cable, or wire being pulled tight by forces acting on opposite ends. The one time of the year that I talk about my time in the Navy is usually now. This is my ship, LHA-2. It was the USS Saipan. When we're out to sea and we need to get supplies, we would pull up alongside of a supply ship, and you can barely see right above my dotted spot there. There's a white line there. That's a cable, rope, wire, etc. That's tension force. We would shoot with a gun, a cable over, and kind of get us connected to that other ship, and then we could run stuff across. You can barely see this little black thing here, kind of going up there. That is a fueling hose. We would take on fuels. We would take on fuel for the helicopter and for the diesels and other things in the ship. Across this wire, they would hang down pallets of stuff, and we'd wheel them across. They'd go in this big door right here that you can't see. Anyway, tension forces. I won't elaborate on my time in the Navy now, but usually I get some questions and have fun talking about it. We had 60 helicopters, and we had the cool airplanes that could take off straight up, the Harrier jump jets. We had 1,500 Marines. The back of the ship would sink down, and they'd have their cool little landing craft go off and do whatever Marines do. So that was my ship. Anyway, tension force, cable, rope, wire, pulled tight by forces on both ends. And, excuse me, sir, I feel like I might have skipped one now. It wasn't working right. Let's see. Nope, that's it for contact forces. Contact forces, forces that are directly in contact with each other. Field forces act without direct contact. One that we're very familiar with, gravitational force, is the force with which the Earth, Moon, or other massive objects attract one another towards itself. We're not going to have to solve any of these problems this year because of the distance learning. We're going to kind of have to focus on just some certain key concepts. Gravitational force is there, and you're familiar with it. Other types of field forces are magnetic forces, which you're also aware of. That's the force of attraction or repulsion between poles of a magnet. There's a picture here. And electrical force. I think at some point during the year, I may have rubbed a balloon on something. If I rubbed a balloon back and forth on my chest and then the balloon would stick there, that was a buildup of electrons. That is that attractive repulsive force due to opposite charges. Lots of negative charge was transferred to my shirt, and the balloon therefore was more positive, and opposites attract, so it was stuck to my shirt. And newtons are measured in, forces is measured in newtons, but that's for the next video. So that's it. I'm going to try to keep this short because I know some of you are having trouble getting your assignments done. So that's it. If you have questions, comments, concerns, get on there and let me know. I do miss y'all. I'd love to hear from you. Thanks for working hard.